Hello students, in today's lecture we are going to study to solve such partial differential equations which are non-linear and their order is 1. So the non-linear partial differential equation of first order. In our previous lecture we discussed the Lagrange's form of linear partial differential equation. But in today's lecture we are going to solve such partial differentials which are non-linear in P and Q. So there are different forms of partial differential equations. So first we are going to study the standard form 1, which is the standard form 1. So the first form or the standard form of the nonlinear partial differential equation is such that the equation will be of this kind, which is this partial differential equation will only contain P and Q terms. This means that there will be no x, y, z terms. Means the terms in the equation will contain only P and Q. So first we are going to describe the working rule, that how we will solve the nonlinear partial differential equation which is of standard form 1. Means that differential equation will contain only partial differentiation with respect to x and y only. There will be no other terms x, y, z. However, if in some cases in a non-linear partial differential equation there will be extra terms, but we will also study how to convert or transform those equations into such form 1, this form. So we are going to describe the working rule to how to solve a non-linear partial differential equation of this form. So this is equation number 1. If we consider the complete integral of equation 1, consider the complete integral of 1 in the form of z equals to ax plus by plus c, where a, b and c are arbitrary constants. This is equation number 2. And then we define that this means that we will get P, that is curly z over curly x will become A, and similarly Q, which is curly z over curly y, we will get B. So from this equation 2, here this thing is p. If you differentiate this equation second partially with respect to x, you will get a, p equals to a. And similarly, if you partially differentiate this equation 2 with respect to y, you will get q equals to b. Then now from equation 1 we can write as f of ab can be written as this will be equal to 0, and from here we can write as b will be equal to phi a. Now if we substitute this value of b in equation 2, we will get z equals to ax plus y phi a plus c. So this is the complete integral of equation 1, which is that this is equation 3, which is the complete integral of equation 1. Note that, students, that this integral contains as many arbitrary constants as there are independent variables in the partial differential equations. So this is the method. First we will consider the complete integral of equation 1 in such a way that z equals to ax plus by plus c. Then p will be equal to a and q will be equal to b. And from here, if we from here we will get the value of b and we will put it in equation number 2. So by this way we can get our complete integral of standard form 1. So let's do an example to understand that how we are going to solve a nonlinear partial differential equation of this kind. So we are given a partial example, a partial differential equation which is p plus q equals to 1. So this is easy, as we can see that this partial differential equation only contains p and q terms. There is no extra terms which contains x, y or z. Clear? And similarly we can have another example like p square plus q square which is equal to 1, or p square minus q square equals to 1. So such nonlinear partial differential equations are of first kind, and we are going to solve it. So consider given partial differential equation which is p plus q equals to 1. Let the complete integral of 1 is the complete integral of 1 is in the form of ax plus by plus c. Let this is equation number 2. And if we partially differentiate it with respect to x, this will be p which is equal to curly z over curly x will be equal to, we will get here a. If you differentiate this equation 2 partially with respect to x, you will get a. And similarly, if you partially differentiate it with respect to y, you will get b. Clear? So p is equal to a and q equals to b. Then from 1 and 2, from these two equations, here p is equal to a and q is equal to b. Then from equation 1, p plus q, which is equal to a plus b, is equal to 1, or b is equal to, this implies that b equals to 1 minus a. So we have obtained the value of b. Now we have to put this value of b in equation number 2. So put in 2. Z will be equal to ax plus 1 minus a into y plus c. So this is the complete integral of equation 1. Clear? Similarly, if we solve this equation as, then consider the solution as solution. The given partial differential equation is, that is p square plus q square equals to 1, and consider the complete integral of 1. The complete integral of equation 1 is z equals to ax plus by plus c. Now from here we can get p is equal to a and q equals to b. Clear? Now to put it in equation 1, equation 1 will become a square plus b square equals to 1. So from here b will be equal to 1 minus a square whole square root. And now if we put this value in equation 2, so equation 2 will become z equals to ax plus 1 minus a square whole under the root into y plus c. So this is the complete integral of equation 1. Now let us consider another example which contains an extra terms other than p and q, and we will see that how we are going to solve it by this method. So we have an example which is x square p square plus y square q square equals to z square. So as we can see here that this equation is not in the standard form 1 form, because it contains extra terms x, y and z. So this equation can be transformed in the standard type 1 form by x square p square over z square plus y square q square over z square equals to 1. Or we can write it as x instead of p, as we know that p is actually curly z over curly x, and q is curly z over curly y. So for p I will write it is x upon z, and this is curly z over curly x whole square, plus similarly y upon z, this is y upon z, curly z over curly y whole square, which is equal to 1. Or we can also write it in such form that this is curly z over z. If I write this z instead of if I interchange these two values and bring this numerator x to the denominator here, so this will be curly x over x, clear, and whole square, plus curly z over z over curly y over y whole square equals to 1. This is equation number 1. Now let this curly z over z is equal to capital Z, capital curly z, and curly x over x is equal to curly x, and similarly curly y over y is equal to curly y. And similarly, to integrate this term, to integrate it, so it will become the this differential will be cancelled with the integral, and we will only get z, clear, and this will be log of z, clear. So here we get the value of capital Z, and similarly log of x equals to capital X, and log of y equals to capital Y. Then equation 1 can be written as this is curly capital Z over curly therefore equation 1 plus this is whole square plus this is curly capital Z over curly capital Y whole square equals to 1. This is equation number 2. So now as you can see that it is in the standard form 1. So let we write it in the form of capital P square plus capital Q square equals to 1. So you can write it as in this form or in this form. This is equation number 2a. So now our required solution. Let the required solution is capital Z equals to A x plus B y plus C. So from here, small p, if you differentiate partially this with respect to x, so from here capital P is, if you differentiate it with respect to x, this will be A, and capital Q will be equal to B. Clear? And from equation number 2, p square plus q square equals to 1. So it will be a square plus b square equals to 1. Or from here we will get the value of b equals to 1 minus a square whole square root. Now we will put this value in equation number, this is equation number 3. Equation 3 will become capital Z equals to a x plus b, sorry, for b we have to write 1 minus a square whole square root into y plus c. But this is not our complete integral, because we have here this z is log of z, x is log of x, and y equals to log of y. So this will be log of z equals to a log of small x plus 1 minus a square whole square root log of small y plus c. So this is our required result of this partial differential equation, non-linear partial differential equation. So I hope you have understood that how we will solve a non-linear partial differential equation which is of standard form 1. If the questions, the given partial differential equation contain only p and q term, then it is easily it can be easily solved by this method. However, if there are extra terms, then we have to eliminate those terms and make it or transform it to such that it becomes a standard form 1. Thank you very much.